In this video, we'll be looking at the quotient rule for logarithmic expressions. Again, just like the product rule, we can utilize this to simplify or expand expressions. Keep in mind, you can also use this to reduce expressions, just like with the product rule. Specifically for this one, we're going to go ahead and recall that let b, m, and n be positive real numbers, as well as b cannot be equal to 1. Again, those stipulations have to hold for this property to be utilized, and the property is log base b of m over n equals to log base b of m, notice how m is on top here, minus log base b of n. So in this particular case, you'll notice here that the property holds true for a division on the inside becomes a subtraction on the outside. Again, make note that in terms of the exponential expression, you have b to the power of m divided by here, b to the power of n, something along those lines. When you combine those two cases here, you will get b to the power of m minus n. So again, the logarithmic expression has the inverse rules such that the division changes to a subtraction, so does the division change to the subtraction, but this happens inside one function and changes to the separation of two functions, while this happens with two functions combining to be one function, and these should be all lowercase here. So, with that rule being stated, we can go ahead and apply this rule to expand types of functions. Again, the question would generally refer to expanding, but the goal of these properties are really for us to utilize them when trying to solve or manipulate equations. So my first expansion question will be log base 8 of 23 divided by x. And we just have to remember again one more time that anytime I have a log of a division, I can separate that division into two separate logs. So this will be log base 8 of, the top goes first, and the bottom becomes the subtraction piece, so log base 8 of x. So that's the expansion of that particular problem. It's important for us to note that the 23 is a prime number and can't be broken up into any smaller pieces. You could use like 23 and 1, but remember that log base anything of 1 is still going to be 0, so breaking this up in any way isn't going to really affect it. Let's look at one more example. We're going to go ahead and expand the natural log of e to the power of 3 divided by 11. Please make note that sometimes those parentheses won't actually be shown. It'll just be natural log of e to the 3 divided by 11, and you should understand that those parentheses are technically there. In this particular case, again, we're going to go ahead and expand this. The most efficient way to expand it is, again, start with the division here because the whole thing is one giant fraction. So I'm going to have the natural log of the top piece minus the natural log of the bottom piece. The natural log of 11 can't be simplified, but the natural log of e to the 3, we have to remember that the natural log is nothing more than log base e. So if this thing is rewritten, it's really log base e of e to the 3. We can ask ourselves the question, what power of e gives me e to the power of 3? And it's 3. So I have 3 minus the natural log of 11, and that's the most simplified form of this quotient rule. This is, again, the simplified version of a quotient rule, where anytime you're dealing with a log function, it will change into the subtraction. If it was a division on the inside, it becomes a subtraction of two separate logs.